Assalamualaikum and greetings everyone. I'm Darush Ashraf. Alongside my group members Gajendran, Krishna Prakash and Muhammad Nazran, we'll be presenting on our assignment about 3D free body diagram representation from actual structure under the guidance of Mr. Hairul Effendi Abdul Maulud. These are the contents of our presentation, starting with the free body diagram, followed by the forces in Cartesian vector form, calculations, and conclusion. Okay, what is FBD? FBD or free body diagrams are useful aids for representing the relative magnitude and direction of all forces that act upon an object in a given situation. The forces method of analysis, also known as the method of consistent deformation, it uses equilibrium equation and compatibility conditions to determine the unknowns in statically indeterminate structures. In this method, the unknowns are the redundant forces. For our assignment, we were given a task to find all the force that acts upon an object. For our group, we have to measure everything that measurable on the cooling tower. This is the equation of static equilibrium, as you can see.
Hello, I'm Begin. Today I'm going to talk about free body diagram. What is free body diagram? FBD. Free body diagrams are helpful tools for displaying the relative magnitude and direction of all forces operating on an object in a given condition. The first step in analyzing and describing most physical phenomena involves the careful drawing of a free body diagram. The size of the arrow in a free body diagram shows the magnitude of the force, while the direction of the arrow denotes the force action. This is the 3D free body diagram with full dimension. This is assumption of load. The structure is in distributed load. Next, the weight is around 125 kg, which is equals to 1226.25 Newton. The distance holder is about 1 meter and all the supports are static at the position. Thank you. Hello, my name is Krishna Prakash and then I'm from BMMA 1/2 and then my metric card number is B0921102661. Okay, now I want to discuss about equation of equilibrium. Okay, as we know from the FBD, A, B, C and D is a static support. For the equation for A is 1.0 I plus 0j plus 0.61k, and before that ijk is representing x, y and z. So now as a continue, B is 1.0 I plus 0.8j plus 0.61k, and C is 0 I plus 0.8j plus 0.61k, and finally D is 0.375I plus 0.6K minus 1.55K, and then the 1.55K is representing the height of the cooling tower. Okay, from the free body diagram, three equation we can be find out the total force that accumulative on the object. So summation z equals to 0 is a formula, and summation fz is a plus b plus c minus 1226.25 Newton, and then the negative 1226.25 Newton is multiple with 9.81 gravity, and also the weight is 125 kg. So as equal we get the 1226.25, and for summation anti-clockwise summation moment x equals to 0. So summation mx equals to b times with 1 plus c times 1 minus 1226.25 times 0.6. The b times with 1 and c times with 1 is representing the 1 meter, the support table. And we also can get the third equation as anti-clockwise summation moment y is negative a 0.8 minus b 0.8 plus 1226.25 times with 0.375. Okay, as we did the three equation above there, we use two of equation to express A and C, which is we substitute equation 2 into C as equation B times with 1 plus C plus times with 1 and minus with 1226.25 times with 0.6 equals to 0. So after we calculate, we get C equals to 735.75 minus B. So after that, we also substitute equation 3 into A, which is negative A times 0.8 minus B times 0.8 plus 1226.25 times with 0.375 equals to 0. And after the equation, A is 455.84 minus B.
Okay, my name is Muhammad Azram Jihan and I will take the slide from here. Static equilibrium take place when all the forces acting on an object are balanced and the object is not in motion in relation to the relative plane. An object which is in static equilibrium is unable to move. This is because all the forces which act on it compensate for one another. Okay, this is a calculation for B. As we can see, after the calculation we get 30.66 Newton, and for C we get 705.09 Newton, and lastly for A we get 429.18 Newton. Lastly, in conclusion, we were able to calculate the reaction and build a free body diagram for the real structure, allowing us to see and describe the relative magnitude and direction of force acting on the real structures. We were also able to estimate the force acting on the x and y axis. The unknown member force can be solved using the equilibrium equation. Finally, we discovered that our structure is in a state of equilibrium. Thank you.